Hello, my name is Lee Presser. This is my show. I speak frequently to very interesting people. Some of these conversations are so exciting, so intellectually stimulating, I thought others might like to listen in. This is the reason we started recording Conversation with Lee Presser.
Welcome to Conversation with Lee Presser. Alternative energy technologies are going to be discussed today. For non-engineers, which is most of us, there's a belief that alternative energy technologies are designed and ready to be deployed. Some believe the conversion to alternate energy systems is being blocked for economic reasons. Today we will be discussing electricity, its generation, distribution, and use in the 21st century. Our guest today is an engineer, Dr. Andy Lozowski. He runs the Power Electronics Laboratory for the Department of Electrical and Computer Engineering at Southern Illinois University in Edwardsville. His research area involves design of energy conversion devices. Professor Lozowski commutes to school on an electric bike using energy captured through roof-mount solar panels. Dr. Andy Lozowski, welcome to Conversation.
Nice to be here.
There is, as I said in the introduction, some belief by some people that we're still on the grid because the people who run the electric system want it that way, that there's a system that is fully capable of creating all the energy that we need if only it were allowed to develop. As an electrical engineer, as someone who works with students who are working on these systems, what is your opinion?
Well, part of this may be true. It is definitely more comfortable for the industry to keep what they have and keep using that. But it's also true that we are able to generate tremendous amount of energy out of renewable sources. Basically, we're talking about solar and wind energy. Mm-hmm. So I would say that's partly true, but not entirely.
Okay. Now, when we were talking on the phone, when we were first talking about having this particular conversation, I want to remind people also that you were here about, I think it was 9 months ago, mm-hmm. and we had a discussion similar to this. But on the phone recently, I said to you that it seems to me that the solar or wind energy that is generated would not necessarily be enough to say if there was a Ford plant or a GM plant or some other heavy industrial plant that there would be enough energy generated by these alternative energy sources to be able to operate those plants. And you said to me, go ahead.
Well, there are two things that we have to consider. One is energy generation and the other one is delivery and distribution. We always think about the power plant or basically an energy source of one point. There is a giant electric plant that delivers energy to all of the distributed users. Mm-hmm. And we could actually imagine this to go the other way around, because we can have one very concentrated consumer of energy like a Ford plant, yes, and many distributed sources of energy and just feed the power the other way. So that's true that if you have a steel mill or an electric consumer that is very concentrated, then it makes solar or wind energy complicated, because you cannot just produce it in one spot. You have to distribute this over the bigger area, because there's only so much power in the solar energy, and there is only a limited number of places where you can put it. However, the surface of the whole entire country is very large, and it's perfectly sufficient to produce all of that power. And we can basically look at the numbers and the statistics to verify whether it's true or not, and look at the numbers.
Mm-hmm. People don't realize or recognize that there actually is a highway on which energy currently travels right now, a system that is called the grid.
That's true.
And there has been talk in the press about the grid and the smart grid, and there's various terms that are being talked about. And I do remember back, at least a decade ago, there was talk about how the grid as it exists right now is not very efficient in taking energy that's created, say, by a solar panel out in the middle of nowhere and feeding that into a system that could be distributed throughout the state of Missouri or the state of Illinois. Could you comment on this, please?
That's true. This is how we control or how we regulate the voltages and the frequencies, and that does make us that puts us in trouble when we start producing power at the other end of the grid and start backfeeding it to the grid. That's one thing, and then the other thing we have to realize that we lose most of the power we generate just on transmission. If you look at the numbers, less than half of the energy that's generated, electricity that's produced, is being used at the other end. More than half is being lost on transmission. Mm-hmm. So we do have super highways of electricity where it's very wasteful.
Mm-hmm. Why is this energy being wasted? What's going on?
Well,
and now I guess we're talking electrical engineering here, but simply put, where the layman can understand, what is happening to this energy as it's moving through the wires?
It just heats up the wires. It's converted to heat, and it dissipates into the air. We have losses on the wires, and the more current you push through the wire, the more loss you're going to have, and it's actually proportional to the square of that. So if you double the current, if you double the amount of energy you try to push, you quadruple the amount of loss.
So if you were to go up to one of these huge towers that you see transmitting electric energy, and you don't touch it, but just put your hand near it, you would actually feel like radiated heat coming off of that?
You wouldn't probably feel this, but over the length of the wire, you will experience that loss. If you're pushing through 1 gigawatt of power, and half of that is lost, then half a gigawatt is being converted to the heat, and that basically escapes with the air. And there is some on induction and also that, but heat is probably the most essential. Mm-hmm.
So this happens on long transmissions. What about on short transmissions?
It practically happens everywhere, and on the long transmission you basically have much longer stretch of wire, so obviously you're going to have that. That's why we're trying to keep the voltages high and current low, because that loss is proportional to the current. So what happens with power is that power is voltage times current. You have to have both. And losses are proportional to the current only. So if you step up the voltage and lower the current, then that improves your situation because you have less current. You can transfer the same amount of power.
Which is why they talk about high voltage lines.
High voltage lines, that's right.
Because you get less loss, and that's why they're doing it.
That's true. However,
and that's why AC won the battle over AC versus DC power then, I guess.
That's because we wanted to use transformers to have an easy way to transfer between low voltage and high voltage wires, because the DC is much more complicated to step up the voltage, and that requires our conversion. Mm-hmm. Transformer is much easier to build, and it's pretty efficient.
Mm-hmm. So let's come back to Earth a little bit and talk about the things that are on people's minds. Again, there is this desire to have a roof-mounted system or some other system that individuals control or a neighborhood can control, in which the power that they need, the electric power that they need, can actually be created by them in their neighborhood. And I guess that some people call this being off the grid. Although they're creating their own little grid is what they're actually doing. In your professional opinion, are we there yet?
The technology that is needed for this does exist. We could start tomorrow to start deploying it. Maybe there is not as much interest in it because of the cost, but I did some calculations just prior to the show and did some statistics, and there are 3 sectors of electrical energy users. We have residential houses, we have commercial, and we have industrial consumers.
Right.
And it just so happens that the industry is using less electrical energy than residential, than houses.
Total amount.
The total amount,
total amount
yes.
of
The total amount of industry is using less than total amount of residential consumers, and the total amount of commercial users.
Right.
And in terms of numbers.
But they are using, the industrial uses a huge amount
It's
concentrated into a small
huge
area.
Huge amount concentrated in one spot versus the houses that are distributed all over the country.
May I hold this up to the
yes.
camera and then there. So
in orange and yellow, we have the energy that is electrical energy that is used by...
So this area here, which is in blue and unfortunately looks
yes.
like it has a hole in it. This down in here, this is your commercial, I mean your home energy.
Yes.
This here is your
commercial.
And then up here, this is
the industrial.
So industrial actually uses a whole lot less than this area down here.
That's correct.
But it's all concentrated into an area. Like if people who are from St. Louis know where Fenton is, they know that there was a Chrysler plant there, so they used a huge amount of electricity in that one small area.
Mm-hmm. That's why we would have to use the grid properly so that we can distribute that energy from distributed resources to a concentrated one spot where you would have the consumer, mm-hmm. which is the industry. And then
so now let me pause right there. Mm-hmm. So in terms of delivering that concentrated burst of energy that you need to run a steel plant, an auto plant, or some other heavy industrial plant, do we have solar, wind, or some alternative energy source which can do that for them, or are they still stuck with using conventional generators, using either coal, oil, natural gas?
Well, they are stuck using those because they are connected to the existing grid, and it is a structure of a tree. Basically, one central point where the power is produced, and then it's being shipped to the loads, and the industrial steel mill or a plant is one of the users. So what we would have to build to allow this would be either an extension of the grid or a microgrid, or change the way we use the existing wires mm-hmm. to be able to allow to route this power in a different way than we do this now.
Does this science exist right now, or is this yet to be invented?
Science exists. You can build a microgrid, which is basically a localized distribution network, so that load can also be a source. And there are ways to control the distribution of that energy. Obviously, it's going to cost money because you'd have to deploy this and probably bury some wires on the ground rather than having them hanging in the air like we do today. But the technology exists. It's just a question of cost. Now, in terms of cost, we'd have to look at the whole entire global picture, because if you want to go to the store and buy a solar cell, mm-hmm. it's going to cost a lot of money. However,
hold that up where the
this is a solar cell.
Hold it to that camera there.
That one is going to produce about 3 watts of power if you hold it into toward the sun. 3 watts of power. To build a panel, you would need to have many of those, and you can make a 200-watt panel that you can still hold in your hands.
So these are all they're hooked together.
They're hooked together in series. And then to build a panel, this is one piece of high-tech equipment. You need a bypass diode or a super diode to complete the production of the panel. The rest of it is just low-tech glue, glass, aluminum, wiring, things like that. Now,
you were explaining to me earlier that these panels are put together in series, kind of like Christmas lights used to be.
That's exactly.
So that when one light burns out, the whole thing goes out, and that's what that diode is for, is to bypass that burnt out light.
That's correct, because what happens is that if you string everything in series, and then you have panels also connected in series, because you want to build up the voltage. There's only half a volt produced from one cell, and you want to build it up to something like 600 volts mm-hmm. or so to make it. And then what happens when they're in series, if a pigeon sits on one cell, it shuts down the whole entire string. So what you need to do is...
So the electricity is coming along, and then all of a sudden it just
cannot
stops.
go through. Yes.
So this device here...
This device here is going to allow to bypass the shade, so that the remaining solar cells in the panel and in the string can still produce the power. So these components, they're available, they can be bought, and the prices are going down. Right now the cells, they're less than $1 per watt.
What did they used to be? Say Say 5 years ago.
We bought this in 2005 for $25.
20, and now it's $1.
And it's less than $1 now.
Aha.
So the prices are going down.
And it creates, and that you said that's...
that will make 3 watts of
3
power.
watts. 3
Yes.
watts.
And
so we're talking 3 watts per dollar.
I made that calculation here. To cover all of that industrial energy consumption, which is about 300 gigawatts today, we would have to have how many people in America? I would say 200 million people in America. Per person, you would have to have 8 200-watt panels mounted someplace. So every person in America, including women and children, would have to have 8 panels to cover industrial consumption of energy.
Just the industrial, not
Just the industrial.
Right.
The total energy consumption just out of the solar energy would involve 34 panels per person. 34 panels.
I mean, is this a panel or this is...
No, that's just
this
a
is
cell.
a cell. So how many of these fit into a panel?
You would have, I would have to calculate that, that would be about 50 of those in a panel.
50 of those.
So you would have to have 850 cells per person to cover the entire electrical energy consumption in America, which is not unheard of. That's actually possible. We would have to also factor in that we only have sun a third of the day that we can use. So you multiply this by 3, and some of the days don't have sun at all. But you know, this is
like
a ballpark number.
The last week.
Like the whole last week or winter, especially certain areas in the country are better for solar energy, others are better for wind energy, because this is just the solar. We also have the other half of that technology, which is the wind tower. You know, the average tower can produce 1 megawatt of power, but they are mechanical parts, so that's a different set of issues there.
Now, is the science, and I recognize this is all science and technology, in the horizon, this one panel, you say, creates 3 watts.
That's right.
Okay. When will it create 6? When will it create 10? When will it create 20?
Well, there's only so much energy you have in the surface area of solar energy coming down. So this cell is about 18% efficient. You can improve the efficiency a little bit, but it's limited. So we would have to basically take surface area of rooftops, roads maybe, and places like that. We would have to basically cover that. That's what the trees do. Basically, they use leaves to produce energy that is in a solid, it's carbohydrates, right? So this is another avenue of progress. We could replicate what the photosynthesis does. It's creating carbohydrates, solid fuel, out of the sunshine.
Now let me ask this. So if, say you were building a new house today, or a new subdivision today, and instead of putting the asphalt tiles on the roof, which is normal,
right?
Could this be deployed on the roof as roofing material?
Certainly.
And act, I mean, and protect the interior so you don't get leaks, but you could then have this
yes, definitely.
Covering the roof.
And you have better life than the shingles that we normally, you know, the life of a shingle, 20 years, life of a solar panel, same 20, 30, or you can make them even last longer. Because there's nothing in them to break. There is a little bit of a degradation of the glass because of the sun and other things, but this can definitely replace the roof and be your roof. And if you, especially if you build a new house, that makes sense because your investment is going to be less visible in the cost of the whole entire house.
Now, the last time you were here, you were telling me that you were working on a system because if you deploy your entire roof with these solar cells, it still generates a relatively low amount of electricity per roof. And therefore, there's not sufficient energy there like to kick on the compressor on your AC or maybe your refrigerator. And you were working on a system of being able to coordinate a series of your neighbor's roofs computerized so that only one compressor would come on at a time. Have you made more progress on that? Are you working still?
We're still working on this. We have PhD students working on that issue as well. We have a small little experimental setup with 5 nodes to exchange the energy between them.
At SIU?
At SIU in our lab, yes. And the whole idea is that it is sufficient, surface area of the roof is sufficient to cover all of your energy consumption on average. However, when you turn on the air conditioner, what happens is that it demands a lot of power instantaneously just to start up.
That's why the lights dim in the house when it comes on.
So the idea here is that, well, that's not sufficient to have that coming from the roof, but you have a few neighbors, and at that time their air conditioners are not starting at the very moment. So you could borrow that energy from them for the moment, and whenever their air conditioner starts up, you could lend your energy in that direction.
So are you saying that if you use this instead of roofing material, that you would be able, on sunny days, to generate enough electricity to run your lights, to run your refrigerator, to run the dishwasher, the clothing washer,
and make some money selling that electricity, because you're going to have an excess.
Oh, really?
You are going to produce
more
than what
and the law says that you can send it back through the grid.
That's correct. You can do that, and the technology now allows that. Most of the meters are going to count backwards and subtract. You probably are going to get some credit from the utilities. That's dependent on the agreement and on state. But there's nothing stopping us from doing this, other than we still have to change the way we distribute energy. That's the job for the utility companies, because they need to take into account that there is now source at the other end of it, and for the grid to not become unstable, they have to factor that into their system. So there is research in that direction too, because the problem is this, that if you want to move energy from here to there, you have to set the voltage higher over here, because by the time it gets there, it's going to be lower. Now, if you start producing energy at the other end, you kind of disrupt this, because they don't expect this to come back. So the system, it tends to go unstable.
So you're unbalancing the system, because they're expecting like water going downhill, and then suddenly you've got the water that's trying to come back up the hill.
Yeah, so if we build something at the other end that distributes the energy among the houses, and you start making a microgrid maybe at the end rather than point loads, then we could fix that situation.
It almost sounds, I mean, taking this to a logical extension, that you were talking about selling energy back to the grid, or the people who are generating electricity using either coal, natural gas, nuclear. That won't be there anymore.
Well, I think that
taken to its logical conclusion of what you're talking about, but it's probably always going to need to be there, isn't it, really?
Yes, but however, we wouldn't have to build any new ones. If we start today, we could just use the utilities that we have, and we can keep adding renewables to just keep with the increase of demand. Because if you look at those curves, they keep climbing up. We're today using 10 times as much electrical energy than in the 50s. And those lines go up and up. So we have to construct new coal plants, we have to construct new power plants. Maybe we could just convert that to the distributed sources and keep what we have so far and keep using it until the life cycle takes them off the grid, and within the course of 50 years maybe we can convert the entire system to more suitable ones.
We have about 5 minutes here, a little less. In Asia, where they are really starting from scratch in many of these countries, because they aren't industrially developed, or weren't, like China, for example, or India. Are they working on this, or are they working on the old model of actually building coal or oil or nuclear plants and designing systems that are similar to what exists now in the United States?
They do both. China and India, they construct a lot of coal plants because they need the power now. They need power to support the industry. However, they do some investment, especially in education, on those topics. A lot of students now coming from India and from China, they come with a very strong background on energy conversion, on renewable energies. They teach their students a lot. There are other countries...
are they deploying, though? They're teaching, but are they also deploying?
They're concentrating on building plants to produce solar cells and to produce the parts for it. They are not deploying as much in those two countries. Other countries that are deploying actually the solar energy, renewable energy, would be Australia, and there are some countries in Middle East that have strong interest in that too. And same thing, education is one thing, but they do a lot of experimentation with the renewable energies. It may be because they know that interest in oil, which comes from there, is going to over time decrease, so they want to invest in something new.
Plus they have a lot of sunlight in that part of the world.
That's another part of it, yes.
Right, so that it actually would work better. I was thinking when you were talking about the losses that occur over transmission lines, that there was talk a few years ago, oh, you got the whole desert out there, you could, but apparently that juice can't get to New York City from out in the desert by Las Vegas.
No, I mean, that's the whole idea of renewable distributed sources, that you use the energy where you produce it. This way you don't have to transmit it over the long distance. And their interest in this would be probably to generate, not generate electricity, but to create equipment and have technological expertise that they could rent out.
Are you satisfied with the progress that's being made here in the United States or worldwide with this conversion from what used to be energy to what we want energy to be?
I would say no. I would like to see more of it, maybe because I'm in this field and that's my area of research, but just objectively speaking, if you have 3 daughters that are asking you the question, how much is that mountain worth to you? And if we're going to destroy the mountain just to dig a coal out of it or degrade the atmosphere, that matters to them, not as much to the present generation. But they're asking the question, is there going to be any oxygen left for them? So this is another motivation for me to look into this.
As an engineer, do you believe that the energy systems that we have been using, in fact, are going to lead to situations that are that dire? And in about 30 seconds here.
Nothing drastic as yet, but over the course of 50 years, looking at the curves going up, it will become dire. 50 years, and we're going to increase the consumption by tenfold. That's going to cause trouble. So over a 50-year period, you think that that maybe we can make the conversion to solar and wind and help this situation out? That would be great. Okay. Thank you very much for being with us today. It went by real quick. We're going to have you back again, and hopefully you'll have more to report in the future. Thank you very much. Thank you. You're very welcome. I've been speaking with Dr. Andy Lozowski. He's a professor at Southern Illinois University in the engineering school there. Tell your friends, if you're seeing this and you want them to see it, go to YouTube. They can see it there. See you all next time. Thank you.